Just so everyone is aware, that's me. I had long hair back then. So my name is Nishant, and today I'll be presenting a talk on hunting path traversal in open source with the emphasis that a fix is greater than find, and it's equally important to fix the vulnerabilities than finding. I believe it makes it a shared responsibility between the researcher and the developer, and takes the sole burden of getting things right from mostly people who are writing open source in their free time. So little bit about me. I am a product security engineer at Atlassian, and I do bug hunting occasionally with open source. I also am on X by the username RealRCherel, so feel free to follow me. Okay, so what is path traversal? Before I start, I wanted to touch base with what path traversal as a vulnerability is. It is sometimes also known as directed traversal because an adversary can use combination of dots and slashes to access certain part of the file system that they shouldn't have access to. And since we are at an OWASP conference, it only makes sense to discuss where does path traversal is within the list. So it has been over there for over a decade, but it lives under the broken access control umbrella now and has a parent sub CWE 22 assigned to it. But the focus of this presentation will be relative path traversal within JavaScript and TypeScript ecosystem, because that's the only language I know how to code in. So what motivated me to look for these issues in the first place? CSI issued a Secure by Design alert last year, highlighting how 55 known exploited vulnerabilities were impacting critical infrastructure. So armed with the basics and this motivation, I started reporting security issues to open source software starting July of 2024. And like I said, the ideology was to fix every finding. And if I were to encounter any bypass, I would try, I mean, any sort of a defended system, I would try and bypass it. So, and why open source? Because it's super transparent. You get to see what the vulnerable code looked like, how it was exploited, and what was done to patch it. And also the fact that it's a $9 trillion resource that, including me, every one of us take for granted. So simple yet harmful, as the name suggests, it is by far the most commonly occurring pattern when it comes to path traversal. And path is a module and has a join method, which basically stitches all these parameters provided as inputs to this method, stitches them up together, creates a path, and then normalizes the resulting path. So a benign user input, something like this, it's safe. It isn't harmful. But an user input like this is where things get tricky. So directory traversal or path traversal, as you call it, the first set of dots and slashes would traverse up the directory. So in this case, this would traverse file. And then the next combination of dots and slashes would traverse var folder, and then we end up with etc, this particular payload. And path.normalize being path.normalize ends up resolving this. So this benign or this harmful user input, which is a relative path, becomes an absolute path. Now, path module, neither the join method are the problem here. It's the unsanitized user input making its way into this method call. So this brings me to our first CVE. It is in URL to PNG, which basically has 80,000 Docker pulls, so somewhat popular. And as the name suggests, it's a service that lets you take screenshots. If you notice, there is the URL as an input and is dark mode parameter, which has the path traversal payload. Let me explain why. So during my code review, I came across this particular constant called image ID, which was taking in these user inputs and feeding them to their respective functions. So Slugify is a function which, in short, basically ensures that only alphanumeric values are extracted out of this URL, and no special symbols or characters make their way. But the parameter value, in this case is dark mode, gets fed to config to string, which is a method that sort of beautifies how the parameters look when you're naming a file. So yeah, and as you can guess, it makes its way to path.join call, and we end up with something like this. and basically we are creating hack.png anywhere within the file system. I chose temp folder because that's usually the writable directory, but depending on what system you're attacking, this could be any. Remember the CISA advisory I talked about? They also suggested a few secure by design principles that you can use. One of them being, hey, either you give a randomly generated name to your file name and store that metadata separately, possibly in a database, or in case the above approach isn't taken, you restrict the number of characters or the type of characters that can be supplied to the file name. So I ended up using the same thing for this. We already had a function slugify that ensured that only alphanumeric values are made or basically make their way into path.join call. So the output isn't pretty, yes, but it gets the job done and is secure. So yeah. This brings us to the other security issue, the unnamed CVD, unmarked CV, I don't know at this point, but it's a popular software, has 2,000 stars, is the self-hosted open source version of Zoom, where you can actually invite people, have meetings, and you can also record your meetings and your screen. So it does so by sending basically this post request to record sync endpoint and has a file name. So I know you notice, everyone has by far noticed that the file name has a path traversal payload, but why am I sending my SSH key with that, public part of it at least? So let me explain why. The code, as you can guess, has an unsanitized user input, making its way to create write stream method. And create write stream method is a developer go-to function when it comes to writing large files. And we are sending WebM chunks to the server, so it only made sense to use this, at least when you're coding in JavaScript. So, and if you notice, there is a flag A, which basically means I'm appending to the file rather than overwriting it. Comes in super handy when you're trying to maintain persistence without being detected. So assuming there is an authorized keys file within the server, then what it would do is add my SSH key to that file. And in a scenario where this file doesn't exist, it would end up creating one. So here's a video demonstration of what is happening in this particular scenario. As you can see, it's hosted locally on my network. I am using the functionality that lets me record my screen. Maybe I should have sped this part up. Oh, I have a screen here. So in a minute, we'll see the server side. This is the server side of things, where we are seeing logs from, or let's assuming a server is running, and then we are seeing these logs. You see the record file, the name. This will come in handy. Just for the demonstration purposes, I'm showing that I am unable to SSH into the victim machine. The record sync endpoint that we talked about, the file name. Remember how it matches with the one we saw in the logs? And then 200 OK response, that means it already has happened, so yeah. The payload that I talked about, I cheated a little bit here because I know the username and the SSH key. So I'm going to hit this request using the burp suit repeater. And then there is a request log which says that, hey, you have saved successfully to this file. And the moment of truth, yay, you are able to SSH into the victim machine. Just for the demonstration purposes, I am going to cat the file, the authorized keys file. And you can see my key was appended rather than overwriting the original SSH key. So yep. All right, so good demo, I know, thank you. But what about the fix? So the author basically went with the regex fix of restricting the characters that could be supplied to the file name. If you remember, there was a specific pattern to the recorded files when it came to naming at least. So I agree, not the best choice. We'll run into performance issues with such a big regex, but it gets the job done. And if you notice, there is this WebM extension check. Now, at the time of reporting, the server wasn't executing these recorded files, so the unrestricted file upload vulnerability or that angle of this issue couldn't be exploited. I tried my best, but by all means, you guys are more than welcome to test it out. Since then, the author has also added additional defenses like using no sniff header, so that sort of reduces the possibility of having a successful attack drastically. All right, so we see similar issues when we actually are hosting a server and serving files. Much to my surprise, writing files to a system isn't the most exploited version of path traversal vulnerability. It's the ability to read these files. So I turned to, for example, let's see this particular code snippet. We have an endpoint public, and we have unsanitized user input, which means, it path.join unsanitized user input. At this point, I think everyone knows what we are going to see. Path traversal vulnerability. Here's a payload which is encoded, and I'm basically trying to fetch the etc password file, and we are able to fetch it successfully. So now I wanted to see how popular static file servers were defending against this. And Vercel, I made this slide before the Vercel the Vercel thing happened where they were able to bypass the middleware, authorization middleware. So probably not the best example now, but back when I was testing, they're still good. They believe in security, so that's nice. Coming back to this slide, the reason I picked Vercel's serve package was because how they were doing things. So this is a code from their package where they're just decoding the URI component on the user provided by the user, and then they're creating an absolute path. All right, path.join. But here's where things get interesting. They're using this package called isPathInside, which, as the name suggests, checks whether or not a child path is within the parent directory or not, and is a very popular NPM package. So inspired by this, I started writing a fix for this endpoint where I'm also doing the same thing, decoding the user input, and then creating a relative path because I had 3 user inputs, and creating an absolute path. This is just to ensure that the code is readable. I could have just done it in one step. And then I also ended up using isPathInside module that basically checks whether or not the child path is within the parent directory. And if it isn't, we return a 400 error. If it does, we proceed with the rest of the code. But not so fast. The NPM package that I used has an advisory which says, hey, do not use it for security purposes. And guess what I did? I used it for the exact same purpose which it said not to use it for. So, but here's a catch to it. If you have a web application server where someone can create a symlink, I think path traversal would be least of your worries. But just for the sake of demonstration, the earlier fix, if I was able to create a symlink, it would bypass my existing defenses. What's the problem? The problem is the package isn't following symlinks, and it doesn't check whether or not a file path exists. So armed with this basics, I started fixing the earlier implementation, and I ended up using real path sync, which basically follows all these symlinks and ensures that you are not giving a file name that redirects you to a different part of the file system. So using that, how do I handle whether or not a path exists? So if a path doesn't exist, the particular function would return null. So we are handling that scenario as well. So with the resolved path, all we are left is a string comparison, and isPathInside was doing it comfortably. So I just ended up using the same API call. And the POC that we saw earlier, the symlink, gets resolved to its original path, and we no longer have hypothetical path traversal vulnerability anymore. All right, and since this fix was so generic, and this is a shameless self-plug, I ended up writing an NPM package. It is out of beta, and it does the same thing that I just explained. So if you are building an agentic AI that does something, I would recommend using this library. Not that I wrote it, but because it works. All right, by the way, this code snippet, this issue was found in Edurar ERP CRM, which is very popular, surprisingly, has close to 2,000 stars and 2,000 forks and 600 stars. All right, I have to rush the slides, but I know every one of you are wondering, hey, you didn't do the most obvious step, which is asking ChatGPT about my problem. And I did. It listed out a bunch of NPM packages that I could have used. Path Sanitizer and Sanitize File Name were the two NPM packages that caught my attention because of the word sanitize in them. And ChatGPT kept on recommending Path Sanitizer to me despite its low popularity. And so nothing fancy, just a simple path traversal payload, and it works. But for a payload which is little complicated and sophisticated like this, it sort of fails. So what is happening here? But before we dive into that, a payload like this, where I have $signs and a bunch of dots and slashes, we still have a working payload. Same for all these characters. In fact, a half encoded payload also works. So what's going wrong? All right, the code is pretty big, so I probably took chunks of it to explain what went wrong. And so they had this fancy regex, which had all these special characters that you can use. And this regex basically was, if you see, there were all other additional checks, but they would deal all these characters right next to a slash as directories, which is valid. And this by itself isn't a path traversal payload. However, the sanitize, a check which basically replaces all these characters ensured that a payload which wasn't malicious now becomes one. So the fix was simple. We reordered how the checks were coming into play. We were sanitizing these special characters before and after. And also we made sure that the dots and slashes were removed recursively and more in depth. Not the best solution, yes, I agree, but it works. This was an issue in Path Sanitizer, like I mentioned. The developers was super nice. He came out of this slumber and then updated the library, allowed me to publish an advisory for it as well. So yeah, that was super nice of them. Battle hardened sanitize file name. Spoiler ahead, I could not bypass it. And it is fairly popular, has close to 2 million downloads. And if you want to install it, there's the command. I was feeling fancy, so I wrote my own fuzzer. 12 positions, 4 possible combinations. And some math later, you have close to 1.6 million combinations. I know, not the best. And like I said, I couldn't bypass it. So I turned to a more professional package, Jazza.js, which is designed to specifically fuzz these NPM packages. And I couldn't bypass it even with 61 million combinations. So it is strong, it holds, and is production ready. I couldn't find any performance issues with this either. For those of you who are wondering, I did try the traditional code review approach. I couldn't find an issue with that either. So yeah. So far we have discussed 3 ways where we can secure these issues. But what is the best method? Now I'm going to say something very contradictory. Developers are the people who are best suited which approach to pick, because they are the ones who know what the feature is intended for. I have a bias towards path validation, not because I have an NPM package that does so, but because it incorporates both the reactive and secure by design principles of security. And like I said, devs should be the ones deciding. And if you are a security engineer, please, please, please ensure that you have some sort of a static scanner that at least catches the basic security issues. All right, sometimes path traversal can be an RBAC issue. So this is what I meant by developers should be the ones picking who gets or what gets in their code base. So this is a code snippet of a functionality where I think at this point everyone knows what the issue is, path.resolve, and then we are making a directory out of it. So if you have a user input that has combination of dots and slashes, you would end up creating an etc folder, and then you end up creating a folder with an etc directory, and then it doesn't look very present, I guess. So this was intended because only admins could have access to this functionality. And like you, I was also wondering, where is the check for admin user? There isn't one. So I read through the code base. They had this check everywhere, pretty much everywhere in all the admin functionalities, but they missed out over here. So hence, a path traversal issue that basically came through an RBAC flaw. All right, so yeah, it doesn't exactly solve it, I agree, but devs know what's best for their code base. This was found in a popular GitHub software called Audiobook Shelf, which is the open source self-hosted version of audiobooks. So it's fairly popular. So I'm going to rush through these slides. I looked at 18 open source software. I'm still looking at a lot of those open source projects, and I was able to discover issues within 10 of these repositories. Now, because of their repetitive nature, I don't have them in my slides, but one thing that they had all in common was they lacked the security policy. So it was difficult for me to report these security issues in a discrete manner, in a responsible manner to these developers. This is what a security policy looks like. You have a policy that lets you describe what versions are supported, what you consider a vulnerability, and how to submit one. As you can guess, I had to ask developers like, hey, for a public repository, if you want me to fix it, I can create a private PR, which would be hidden from general public. So summary is basically, hey, this is why path traversal vulnerabilities happen. Stick to a secure by design approach or to an NPM package that I wrote. And please install a SAST tool. Scan your code. And if you're an open source developer, kudos to you. Thank you for developing for free. If you're interested, all my findings are public. You can scan the QR code. Or if you're as paranoid as I am, feel free to use the link. Questions if anyone has any? Yeah.
Besides, like when you use ChatGPT to find your NPM packages, how do you find like the next open source project to tackle?
That's a good question. I came prepared. So basically, I was using this GitHub query to find out what packages or what open source software that I wanted to hit on. Basically anything which is popular, so that I don't end up wasting my efforts. If no one is using it, okay, all right, I take back my statement. Even if no one is using it, it's best practice to use a secure code. But the idea was to get some clout. And also the fact that it has to be in active development. As I mentioned, JavaScript, because that's the only language I'm good at. But yeah, I hope that answers your question. So. Anyone else?